What if everything is an illusion? Close your eyes. Imagine standing in front of a vast wall perfectly black, smooth, and infinite. You reach out your hand, but instead of touching substance, it dissolves into light. Nothing is solid. Nothing is fixed. What if everything, your body, your memories, even space and time, isn't as real as it seems? What if the universe itself is a projection? This isn't science fiction. It's one of the boldest, most mind-bending ideas in theoretical physics today, the holographic principle. The suggestion that our entire 3D universe might be a shadow, a projection of information encoded on a distant 2D surface. In this documentary, we'll journey into black holes, quantum information, string theory, and the boundaries of space and time to uncover whether reality is truly holographic. The origin of a radical idea. In the 1970s, a Dutch physicist named Gerard 't Hooft was studying black holes and quantum gravity when he made an astonishing proposal. What if all the information contained in a region of space could be described by information on its boundary? Later, the idea was expanded by Leonard Susskind, who connected it to string theory. Susskind argued that just as a hologram stores a 3D image in a 2D format, so too could the universe store all its physical information on a 2D surface and yet create the illusion of 3D reality. They weren't alone. The proposal was deeply rooted in attempts to solve one of the greatest paradoxes in physics, the black hole information paradox. Black holes, according to general relativity, seem to destroy everything that falls into them, including information. But in quantum mechanics, information can't be destroyed. Something had to give. The solution? Information may never really be lost inside a black hole, because it could be encoded on its surface. That's where the holographic principle was born. These early ideas were controversial, but they ignited a scientific revolution, pushing physicists to rethink the nature of space, time, and reality itself. Black holes and the edge of reality. Black holes are more than cosmic monsters. They are laboratories of reality. In 1974, Stephen Hawking shocked the world by showing that black holes aren't completely black. They emit radiation now known as Hawking radiation due to quantum effects near the event horizon. Over time, this radiation can cause a black hole to evaporate. But if the black hole vanishes, what happens to the information about the matter that fell into it? If it disappears completely, this violates quantum theory. If it's preserved, where is it stored? Hawking, Susskind, and others debated furiously. The resolution began to take shape. Information about what falls into a black hole isn't stored in its interior, but on its event horizon, the 2D surface. This led to the incredible realization: perhaps the entire universe works the same way. Just as a black hole encodes its contents on its surface, so might the cosmos. This isn't just a quirky idea. Black holes remain one of the most active research areas in physics, and they continue to offer clues to the fundamental structure of the universe. The mathematics of holography. In 1997, physicist Juan Maldacena provided a stunning breakthrough. He proposed a duality between two radically different theories: a gravity theory in 5D spacetime including our familiar dimensions, a quantum field theory without gravity on the 4D boundary of that space. This became known as the ADS or CF correspondence, a precise mathematical realization of the holographic principle, although the specific geometry anti-de Sitter space doesn't describe our universe exactly. The concept opened the door to viewing reality as fundamentally encoded on boundaries. Gravity and space-time may emerge from quantum information on a lower dimensional surface. Time itself may be emergent, not fundamental. Think about that. The flow of time, the expansion of space, the laws of physics all could arise from a 2D informational code. Modern research continues to explore these dualities in more general geometries. Holography is no longer a fringe idea, it's a foundational tool in modern theoretical physics. The universe as information. At the heart of the holographic principle is one strange idea. Information is more fundamental than matter. Everything we see around us may be the result of bits, tiny units of quantum information interacting, processing, and evolving. This isn't just theory. Scientists like Seth Lloyd and John Archibald Wheeler have proposed that the universe is fundamentally a quantum computer processing information at the smallest scales. Wheeler's famous phrase, "it from bit," suggests that every particle, every field, and every interaction arises from binary yes-no choices from logic, not substance. Your body, your thoughts, the sun, the galaxies all might be emergent phenomena built from pure information, unfolding on a lower dimensional surface. Digital physics, cellular automata, and entropic gravity are all part of this emerging narrative. If true, it would mean that the universe is more akin to a vast computation than a physical machine. Testing the holographic hypothesis. If the holographic principle is true, can we test it? Physicists are trying. Some look at cosmic microwave background data, searching for statistical fingerprints of a holographic geometry. Others examine quantum entanglement and the structure of spacetime itself. Experiments like the Fermilab holometer aim to detect holographic noise, tiny jitters in spacetime that might reveal its digital nature. So far, no conclusive evidence, but hints keep coming. Theories involving emergent gravity, tensor networks, and quantum error correction are painting a picture of spacetime as an illusion, built from deeper rules. If true, it would mean that you are not truly in space, but rather, your entire reality is a projection from a distant, invisible boundary, and in that case, everything you see is not what it seems. Consciousness and the hologram. Some thinkers go even further. Could consciousness itself be a holographic phenomenon? Neuroscientist Carl Pribram and physicist David Bohm suggested that the brain doesn't store information like a computer, but like a hologram, distributed, overlapping, resilient. Perhaps reality and mind are both projections, not separate, but reflections of deeper structures. Quantum consciousness remains speculative, but one thing is clear. The holographic principle forces us to rethink what we mean by real. Maybe the boundary between mind and universe is itself an illusion. This raises profound questions about free will, perception, and the unity of experience. What does it all mean? If the holographic universe is real, space is not what we think it is. Time may be an emergent illusion. Our world is deeply connected to an invisible boundary we cannot see. Information is the true fabric of reality. This isn't just theory. It's a call to rethink physics, philosophy, and perception itself. We may live inside a cosmic illusion, but that illusion is governed by rules we're beginning to decode. We are shadows of code. Awakening. Beyond the hologram, what's next? What lies beyond the 2D surface? If the universe is a projection, then what is the projector? Some physicists speculate that even the 2D code might itself be emergent from entanglement, causal networks, or something even deeper, beyond quantum theory. Theories of the multiverse suggest that our hologram might be one of countless others. Others explore links between holography and loop quantum gravity, quantum geometry, or even cosmic consciousness. Perhaps reality is layered with each level, being a shadow of something more fundamental. The journey doesn't end with a hologram. It may only be the beginning. The wall and the light. Remember that wall of blackness at the beginning. Maybe it's real. Maybe we're seeing its projection. Maybe we've spent millennia staring at the shadows on the wall, unaware that reality lies not within the cave, but on the wall itself. The holographic principle doesn't diminish the universe. It reveals how much more there is to understand and perhaps how deeply we are already a part of it. If you found this journey fascinating, subscribe for more mind-expanding cosmic explorations.